A pleasant morning. Our topic is based on Smart Health Monitoring System. Our team members are Ramnalakta, Bersi, Bhuvaneshwari, and Geeta Priya. Let me start with my topic. Smart Health Monitoring System is a vital topic and an important research field today. One of the most promising applications of information technology is in healthcare management. Healthcare is moving from a reactive approach to a proactive approach characterized by early detection, prevention, and long term management of health conditions. This system is more useful for elderly people as they are more prone to chronic diseases and need continuous health monitoring. Hence, design and development of low cost instruments using modern technology is to be given a great concern to facilitate the access of every patient to have a satisfactory medical service.
Here I'm going to explain the components which is used in this project. The first one is Arduino Uno. Arduino Uno is a microcontroller board based on the Atmega T28P. It has a 14 digital input and output pins. It's simply connected to a computer with the help of USB cable. Next one is GSM model. GSM model is a wireless modem that works in the wireless network. It sends and receives the data to the radio waves. Working of GSM. It starts with commands 80, which means attention, and ends with character. Then the command 80 is given to the GSM module with the help of PC. The RX and TX of the Arduino is given to the TX and RX of the GSM model respectively. Coming to the next point, here we use three sensors: temperature sensor, toxic gas sensor, and heart rate sensor. First one is temperature sensor. It is a device which is specifically designed to measure the hotness and coldness of an object. Here we use a LM35 temperature sensor. With LM35, it is used to measure the temperature accurately than with thermistor. It has a low input impedance and linear output. And next one is toxic gas sensor. Gas sensor MQ9 module is useful for detection of gas leakage. It is suitable for the detection of carbon monoxide, methane, and liquefied petroleum gas. The sensitivity of the sensor can be adjusted by using the potentiometer. And last one is heart rate sensor. It is used to measure your heart rate. The the sensor has an optical heart rate sensor with amplification and circuit for noise detection, giving most reliable and fast pulse readings. To measure the sensor, we just need to clip the sensor into your earlobe or fingerprint.
Now I'm going to explain the working of our project. Here we have gas sensor, GSM module, LCD 20x4, Arduino board, temperature sensor, virtual terminal, and the heartbeat sensor. This is the gas sensor MQ9. It detects harmful gases such as carbon monoxide and other combustible gases. Here we also used a logic toggle. If it is 0, it indicates the absence of gas, and if it is 1, it indicates the presence of gas. If presence of gas is detected, that is, if the value in the logic toggle is 1, the LED glows, buzzer sounds, and the fan is automatically turned on to remove the harmful gas. And then alert message is also sent to the caretaker through the GSM module. And after the gas is eliminated, the LED and the fan will be turned off automatically. And in real time, we no need to use the logic toggle as the sensor can sense the presence of gas by itself. The presence and the absence of gas is also visually displayed in the virtual terminal. And next, this is the temperature sensor LM35. It is placed in the oral and the wrist of the patient, and it continuously monitors the temperature of the patient. If there is a high increase or decrease than the normal range, the LED glows, buzzer sounds, and the alert message is sent through the GSM module to the caretaker. And if the temperature is normal, the LED does not glow and the buzzer does not sound. And next is the heartbeat sensor, and this is the LCD 20x4. Here we will display the measured heartbeat. In this project, we are going to find the heartbeat per minute, also known as BPM, beats per minute. Here we have a variable resistor. By changing the value of the resistor, we can change the heartbeat pattern. Right now we have resistance value as 22%. Now we need to click on the button. If we click on the button, the heartbeat sensor starts to calculate the current heartbeat. If here we are calculating the heartbeat for 10 seconds. In 10 seconds, it counts the heartbeat, and after that we simply multiply the heartbeat by a factor of 6 because we want to get the heartbeat for 60 seconds, and thus the heartbeat for per minute is calculated. Now again, if we reduce the resistance value further, we will find that the heartbeat is counting very fast. It is found that in previous case we got heartbeat as lower value, and in this case we got heartbeat higher value. This is how heartbeat is monitored continuously, but in real time, instead of placing a variable resistor for calculating the heartbeat, we should just place our fingertip on the sensor and it would calculate the heartbeat.
The advantages of this project are: it allows sending data from patients to healthcare professionals in real time, and in case of an emergency, an alarming signal is sent to doctor for easy monitoring. Thus, it bridges the gap between the doctor and patients. It is best to be used on rural areas, and it is easy to operate. People can spend more time at home with their families rather than hospitals, since it allows patients to maintain independence, prevent complications, and minimize personal cost. This advantage is of great importance for people with long term illnesses and elderly people who have to communicate with healthcare professionals more often. And also, when compared with compact sensor, it gives better performance. Speaking of disadvantages, it is not accessible for everyone since it requires good broadband connectivity, which is hard to achieve for small healthcare institutions and rural hospitals. Unproved accuracy of devices results in doubtful reliability. Some patients are afraid that their private health data can be obtained by third parties and used for dubious purposes, which is also a disadvantage. Thus, standardization is required for data exchange and interoperability among multiple components. Future scope of work includes IoT-based remote patient monitoring system can be enhanced to detect and collect data of several anomalies for monitoring purposes. Multiple parameters like blood pressure, sugar level, respiratory information, brain signal monitoring, home ultrasound, tumor detection, etc. can be included in the future to improve the efficiency of the wireless monitoring system in biomedical field. A graphical LCD can be used to display a graph of rate of change of health parameters over time. For further more improvement, the whole health monitoring system which we have framed can be integrated into a small compact unit as small as a cell phone or a wristwatch. This will help the patients to easily carry this device with them wherever they go. At last, in addition with medical application, we can use our system in industrial and agricultural application by using sensors like humidity sensors, fertility check sensors, etc. Thank you.